Welcome to episode 19 of your CYSA Plus Prepcast. In this episode, we focus on one of the most vital foundations of cybersecurity analysis, understanding how operating systems work. As a cybersecurity analyst, your job requires you to detect suspicious activity, investigate threats, and understand the mechanisms behind each system-level event. Whether you're looking through process lists, scanning logs, or tracing privilege changes, your ability to understand and interpret operating system behavior directly impacts your effectiveness in detecting and responding to security incidents. The CYSA Plus exam places great importance on this, and in real-world scenarios, these skills are non-negotiable. Let's begin with the analyst's perspective on operating systems. Most security incidents that require investigation involve activity taking place at the system level. Malware runs processes, changes file attributes, manipulates permissions, and modifies registry entries or system configurations. These are all OS-level activities. To understand, detect, and remediate these threats, analysts must be fluent in how the operating system behaves under normal conditions and how it behaves under attack. Without this knowledge, key indicators of compromise can be missed, and effective remediation becomes almost impossible. The two main operating system families you must know well are Microsoft Windows and Linux. These platforms dominate enterprise IT environments and appear heavily throughout the CYSA Plus exam. Both operating systems offer logging, permission management, process monitoring, and network capabilities, but each implements them differently. Windows offers an extensive event logging system and a centralized registry, while Linux provides fine-grained control through configuration files and command line utilities. Analysts must be able to navigate both ecosystems with confidence, as incidents often span across platforms. Starting with Windows, one of the most essential OS elements an analyst must understand is the Windows Registry. This is a hierarchical database that stores configuration settings for the system, installed software, user accounts, and services. Malware often uses the registry to establish persistence, hide configurations, or modify startup behaviors. Analysts must be able to navigate registry hives, especially hkey_local_machine and hkey_current_user. You should recognize signs of manipulation, such as entries under run or run once keys that execute malware on startup. You may be asked on the exam to analyze a registry path or determine which hive is likely to contain evidence of persistence. Windows file systems, especially NTFS, offer a robust set of features that support security analysis. File permissions, ownership, timestamps, and access control entries can all be used to identify unauthorized access or privilege escalation. You should be able to interpret access control lists and identify when inheritance is overridden or when permissions allow unintended access. Analysts also rely on NTFS alternate data streams, which can be abused to hide malicious payload. Expect to see questions that ask you to evaluate file-level permissions or spot anomalies that suggest insider misuse or lateral movement. Analysts must also develop fluency in identifying system processes. Windows has hundreds of legitimate processes that run in the background, and many malware variants disguise themselves using similar names. You should be able to differentiate between critical processes, like svchost, LSA, and winlogon, and malicious processes that attempt to mimic or inject into these services. Analysts must also recognize process trees and identify when parent-child relationships are suspicious, such as PowerShell spawning CMD or MSHTA executing a script unexpectedly. You may be tested on how to investigate a suspicious process, or which utilities to use to validate process behavior. Windows Event Viewer is another core area for analyst expertise. Security event logs are invaluable for identifying user logins, failed authentication attempts, privilege escalation, policy changes, and system restarts. Analysts must understand common security event IDs such as 4624 for successful login, 4625 for failed login, and 4670 for permission changes. Application and system logs reveal service failures, software errors, and update activity. Analysts must be able to filter these logs, extract the timeline of an incident, and validate whether activity is part of normal operations or an active intrusion. System hardening is another core competency. Analysts must know how to evaluate whether an operating system has been configured securely. This includes disabling unnecessary services, limiting the number of administrators, enforcing password complexity, patching known vulnerabilities, and using group policy objects for consistency. Hardening also involves ensuring that firewalls are enabled, ports are restricted, and event auditing is active. The CYSA Plus exam may present a system configuration and ask you which settings weaken the security posture or which actions are recommended to improve it. User account management is an essential part of system security. Analysts must understand how users are added, how privileges are assigned, and how attackers attempt to escalate privileges. You must be able to spot shadow admin accounts, detect unauthorized group membership changes, and analyze account usage patterns. In Windows environments, this also includes understanding Active Directory group policies and how centralized authentication works. You might be asked to review audit logs to identify accounts that are overprivileged or behaving abnormally. Familiarity with Windows command line tools significantly enhances your effectiveness. Analysts use PowerShell to automate tasks, gather logs, query services, and export event data. Tools like netstat show active connections, while task lists reveals running processes. Command prompt utilities such as whoami, ipconfig, and netuse help analysts determine system state, active sessions, and network configuration. Understanding these commands allows you to quickly gather evidence during investigations. Expect questions on command usage, interpretation of outputs, and which tool is most appropriate for specific scenarios. Each of these tools and techniques contributes to an analyst's ability to monitor, detect, and investigate threats. Being proficient with Windows is not just about clicking through menus. It is about understanding the architecture, recognizing expected behavior, and responding decisively when something is wrong. Whether it is malware persisting through registry keys, unauthorized file access, or privilege escalation, analysts must know what to look for and how to validate it. These skills are fundamental both to passing the exam and to succeeding in any cybersecurity analyst role. For more cyber-related content and books, please check out cyberauthor.me. Also, there are more security courses on cybersecurity and more at baremetalscyber.com. Now that we've covered Windows operating system concepts, it's time to turn our focus to Linux. While Windows dominates many enterprise desktops, Linux powers a large portion of servers, cloud workloads, network appliances, and embedded systems. For a cybersecurity analyst, the ability to understand, monitor, and secure Linux systems is just as important as Windows proficiency. Many threats target misconfigured Linux services, unpatched kernels, weak SSH setups, or poorly monitored daemons. The CYSA Plus exam requires you to recognize Linux file structures, interpret logs, analyze processes, and apply system hardening techniques that are vital for maintaining secure environments. Let's begin with the Linux file system. Unlike Windows, Linux follows a strict hierarchical directory structure. At the root is the /, followed by critical directories like /etctricity for system configurations, /var/log for logs, /home for user directories, and /tmp for temporary files. You need to understand how files and folders are organized so you can spot unauthorized changes, unusual scripts, or misplaced files that could indicate compromise. For example, malware hiding in /tmp or sensitive scripts planted in /etcit/initd should immediately raise red flags. The exam may ask you to analyze file paths and determine whether certain files are suspicious or improperly located. Understanding Linux file permissions is also essential. Linux permissions are represented through read, write, and execute rights for 3 categories: the owner, the group, and others. You'll often see them in symbolic forms such as RWXR or XR644 or 644. These permissions determine who can access or modify a file, which is a key control in securing sensitive scripts, user data, and system binary. Analysts must be able to recognize when permissions are too broad or when files are accessible to unauthorized users. On the CYSA Plus exam, You may encounter questions that require you to calculate or interpret permission values and decide whether they violate security best practices. System configuration in Linux is largely controlled through flat text files located in / etc. These include settings for services like SSH, cron jobs, user accounts, network configurations, and startup services. Analysts must be able to navigate these files, identify risky settings, and recognize unauthorized changes. For example, an SSH configuration file allowing root login without key authentication would represent a major risk. You must also be able to detect when scripts are inserted into startup routines to maintain attacker persistence. Expect exam scenarios that present sample configurations and ask you to determine whether they conform to secure standards. Log interpretation is a critical function for analysts working on Linux systems. The primary logging mechanism is islog, which routes messages to files located in /var/log. You should be able to interpret logs such as authlog for authentication attempts, kernlog for kernel messages, and messages, or SILOG, for general system activity. Analysts must also know how to examine application-specific logs such as Apache access logs or database transaction logs. These logs provide evidence of login attempts, service restarts, file access, and network activity. You'll need to recognize patterns that indicate brute force attempts, privilege escalation, or unauthorized configuration changes. Linux process monitoring is another essential skill. The PS command displays running processes, while top or htop provides real-time usage stats. Suspicious processes may include those running under unusual users, executing from temp directories, or consuming large amounts of memory or CPU. Analysts must also know how to examine process trees to trace a parent-child relationship. For example, if a legitimate service, like Apache, spawns a shell process, that could indicate exploitation. You'll be tested on your ability to spot process anomalies and determine what actions to take to investigate or contain them. Man-li tools are the analyst's primary interface with Linux. Utilities like grep, AUSC, and SED are used to search and manipulate text files. The lsof and netstat commands help analysts identify open files and active network connections. tcpdump is used to capture and analyze network traffic directly from the interface. The find and locate commands are useful for searching large file systems quickly. Proficiency with these commands enables you to perform incident response tasks such as collecting indicators, isolating compromised files, and verifying process behavior. The exam may present output from these tools and ask you to interpret the results or identify next steps. Software installation and updates in Linux are managed through package management systems. In Debian-based systems, this is done with apt, while RHEL-based systems use yum or DNF. Attackers often install backdoors or tools by silently modifying packages or installing unapproved software. Analysts must know how to audit installed packages. You may be asked which command reveals recently installed software, or how to determine whether a binary has been replaced with a malicious version. System hardening in Linux involves multiple strategies. These include configuring firewalls using IP tables or firewalled, enforcing mandatory access control through tools like SELinux or AppArmor, and disabling unused services. SSH must be secured by disabling root logins, enforcing key-based authentication, and using non-standard ports if appropriate. You should also understand how to apply file integrity monitoring, enable audit logging, and enforce password policy. On the exam, you may be asked to evaluate a Linux server configuration and identify weak points or recommend hardening steps. Cron jobs and scheduled tasks are often leveraged by attackers for persistence. These jobs are scheduled using cron tab and executed at specified intervals. You should know how to list cron jobs for users, examine their content, and identify potentially malicious entries. Suspicious cron jobs might execute from unknown paths, use obfuscated file lens, or run scripts that download and execute content from the internet. Analysts should also monitor cron directories for unauthorized scripts. CYS A+ exam questions may test your ability to identify which cron entries are legitimate and which may be signs of compromise. Lastly, modern Linux environments increasingly include containerization and virtualization technologies. Docker is the most common containerization platform. Analysts must understand how Docker isolates applications, how container images are built, and what security considerations apply to container orchestration. Containers may share the same kernel, meaning a compromised container could potentially lead to privilege escalation. Analysts should monitor Docker logs, validate image sources, and scan container images for vulnerabilities. Expect the exam to include basic container security principles or scenarios involving multi-tenant isolation issues. To summarize, Linux operating systems offer a powerful and flexible foundation for enterprise computing, but they also require close monitoring and skilled analysis to secure properly. As a cybersecurity analyst, your ability to understand Linux file systems, process behavior, permissions, logs, and command line tools directly affects your ability to detect and stop threats. By mastering these topics, you not only boost your readiness for the CYSA Plus exam, but also become significantly more effective in any operational security role. Keep practicing your commands, exploring system logs, and reviewing configurations.
Thanks for listening.
To reinforce everything
To learn
you've
more
learned
about
cybersecurity, please visit baremetalcyber.com. There you will find best-selling books, videos, and even more free cybersecurity training courses. Please subscribe to the Prepcast and our various podcasts. And thanks for listening.